Okay, so with quadratics, we had talked about square roots, complex numbers, we've talked about the solve with the square roots, and we've talked about factoring. So the next thing I want to talk about is how to graph. What do we need to know about graphing? What are the attributes that you need to know about a graph? First thing, if you're looking at a quadratic function, this is what the standard form is. So f of x equals ax squared plus bx plus c. That's how the quadratic formula is derived from, which is derived from completing the square. If you're talking about how it's set up, this is the standard form of a quadratic. Now I did both graphs that are based around where the vertex is 0, 0. If it is a positive x squared, it looks like this. Negative x squared, it goes down. So you always were taught kind of like smiley face and frowny face when you first learned these. The vertex is the point where the graph changes. So like for this, both of these are at 0, 0. It's either where the minimum is. If the graph goes up, it's a minimum. If the graph goes down, it is a maximum. So a positive x squared goes up, has a minimum value. Negative x squared goes down, has a maximum value. The axis of symmetry is a line that makes the graph symmetrical. So it folds it in half. So if you find the points on this side of the graph, those are the same on the other side. It's symmetrical to wherever the axis of symmetry is located. So like in this case, the axis of symmetry is at x equals 0. They're always a vertical line. Everything we're talking about, the graphs are going up or down. They don't go sideways. Okay, you do see parabolas that are like that are not functions when we get to conic sections, but everything you're dealing with is a function. Every graph should be vertical. It goes up or it goes down. Okay? So the rest of these are some definitions on things that you need to know. So the y-intercept, that is where the graph crosses the y-axis. If you're looking at an equation that's in standard form, it's going to be your c value. C value is what's at the very end. Okay? The formula for the axis of symmetry, it's always going to be x equals because it's a vertical line. So the x equals lets us know it's a vertical line, and it's the opposite of b, that's the number in front of x, over 2 times a. That is how you get your axis of symmetry. Now the axis of symmetry always cuts through the vertex, the changing point of the graph. So when you're talking about your vertex, this number, that value, okay, yes, this is a line, but that value of x, that is your x value in the vertex. How you find the y value is you plug in the x value into whatever your equation is. So you'll plug that value in for x. That's going to give you your vertex. So like I said, for these, the vertex is 0, 0. The vertex is not always 0, 0, just on the graphs that I drew here. Okay? Roots, which are also called zeros, which are also called solution sets, which are also called x-intercepts. That is where the graph crosses the x-axis. So on these, they only have one root because it only crosses right there at the vertex. You could have one answer, you could have 2 answers, or you learn 0, okay, if it doesn't cross. Now because we've now talked about complex numbers, you are going to have roots. They're just going to be complex roots if it doesn't cross. And we'll talk about that later. You don't have to know about that tonight, okay, when you're watching your video, but we'll talk about that later. Okay, and then you have to find the maximum or minimum value. Does it have both? It depends on what the graph is. So if the graph is a positive x squared, it's going to have a minimum. If it's a negative x squared, it's going to have a maximum. That value, when you find the value, that is the y value in the vertex. Okay? And then domain and range. This should not be new. This should be something that's ingrained in your head from Algebra 1. Domain. Domain are your x values. If I'm looking at these graphs, they have arrows that go on in both directions. Doesn't matter if it is a positive or a negative graph. They have arrows that go in both directions, which means it's going to cover every single x value. So that means my domain for all of these is going to be from negative infinity to infinity. But my range, which is my y's, it doesn't go across the whole set of y points. Okay, because this graph has a vertex, it's either going to all go up or it's all going to go down. So when I'm talking about my range, depending on what my graph looks like, if it's a positive x squared, it's going to go from that y value all the way to infinity. If it's a negative x squared graph, it's going to go from negative infinity up to that point. Okay? So I'm going to give you a second to make sure you get this all written down, whatever you want to write down for your notes. And then we're going to do 2 examples. Okay, now you may not have gotten everything written down that you wanted to. Go ahead and pause the video if you're not ready to move on. We're going to do 2 examples. And these 2 examples have the same directions you're going to see on your homework, which I'm going to assign tomorrow. So the only homework you have right now is just to watch this video before you come to class. Okay, so we're going to find the y-intercept, we're going to find the axis of symmetry, and the vertex. Then we're going to make a table of values, or a t-chart, what we call it, and then we're going to graph. So I have to find my y-intercept, my axis of symmetry, and I have to find my vertex. Okay, well the y-intercept is where the graph crosses the y-axis. Since we do not have the graph drawn yet, we can use our shortcut, which over here it says the y-intercept is just c. Okay, why does that work? Well, the y-intercept is when x is 0. So if both of these x's are 0, all I'm left with is my c value, which is 15. So my y-intercept is 15. You can write that as 15, or if you want to get in the habit of writing it as a point, it would be 0, 15. You do not have to graph your y-intercept if it doesn't fit on your graph. We're just talking about how do we find that. Okay, my axis of symmetry. It's always going to be an x equals equation. So x equals, then my formula says the opposite of b over 2a. Well, if my b is negative 8, my opposite of negative 8 is positive 8 over 2 times a, 2 times 1, which is 2. So 8 divided by 2 is 4. So that means my axis of symmetry is x equals 4. So I have my y-intercept, I have my axis of symmetry. Okay, then my vertex. My vertex says the first part is negative b over 2a, which is this number. Okay, then if I have my y, I plug that number in. So I'm plugging that number in up here. So 4 squared is 16. 4 times negative 8 is negative 32. So 16 minus 32 is negative 16. Plus 15 is negative 1. Okay, axis of symmetry is the line. Vertex is the point. Okay, then we're going to make a table of values, and we're going to graph. On your table of values, this is symmetrical. So first thing I would do is put in your vertex. And then you're going to do 2 numbers on each side. So 2 numbers bigger than 4 would be 5 and 6. 2 numbers smaller would be 3 and 2. Now, once I find 5 and 6, if they're equidistant away from the other numbers, those just reflect on the other side. So if I put in 5, 5 squared is 25. 5 times negative 8 is negative 40. So 25 minus 40 is negative 15. Plus 15 is 0. Six squared is 36. Negative 8 times 6 is negative 48. So 36 minus 48 is negative 12. Plus 15 is 3. Now, you can plug in 3 and 2 if you want to, but these are symmetrical, which means those numbers are going to be the same. They mirror each other. So when I put in 3, I'm going to get 0, and when I plug in 2, I'm going to get 3. If you don't believe me or you're not sure if you did it right, plug those in and solve. 3 squared is 9. 8 times negative 3 is negative 24. 9 minus 24 is negative 15. Plus 15 is 0. 2 squared is 4. Negative 8 times 2 is negative 16. 4 minus 16 is negative 12. Plus 15 is 3. And then we're going to graph it. So I have 4, negative 1, 5, 0, 6, 3, 3, 0, 2, 3. So my graph looks like that. Okay, now I'm not asking you to tell me this for this problem, but if you were asked to find the roots, that's where the graph crosses the x-axis. My answers to this problem, my roots, would be 5 and 3, because those are where it crosses the x-axis. Okay? I'm not asking you that in this problem, but you will be asked later what are the roots. Okay, for the second example, we're going to find if the function has a maximum or minimum, we're going to find the value, and then we're going to find domain and range. Well, domain and whether it's a maximum or minimum should be the easiest part. If it is a minimum, that means whatever x squared is positive. If a number for x squared is negative, it's a maximum. So if I'm looking at this, this is a positive 2x squared. That means this graph has a minimum. We don't know what the value is yet, okay? But we also know the domain. Since this graph goes on forever, and arrows on both ends, all the x's are defined from negative infinity to infinity. Okay, and then we're going to talk about the range as well. We got to find the value in order to know the range. Okay, now we do know, because it's a positive x squared, we don't know what this y value is, but we know it's going to be this first scenario. So we know it's going to go from some value to infinity. Okay, how I find that is I'm going to have to find the y value in the vertex. Well, in order to find the y value in the vertex, we're going to have to find the x value first. Because to find the y, we plug the x value in. So if I do the opposite of b over 2a, this would be negative 4, because b is 4, so opposite of 4 is negative 4, over 2a, a is 2. So negative 4 divided by 4 is negative 1. Okay, that's not my value. That's just the x number. That's the x coordinate. To find the y, you have to plug that in. So negative 1 squared is 1 times 2 is 2. 4 times negative 1 is negative 4. Minus 6. Well, 2 minus 4 is negative 2. Minus 6 is negative 8. So my y value, or my value of this minimum, is negative 8. Which means my range is from the y value to infinity So my range is from -8 to infinity. Okay, now I'm not gonna be super picky on this, but these will be included, so you actually technically would have a bracket there around the number. Infinities never have brackets because they don't ever stop, they go on forever, it doesn't include it. But the numbers that do include it and touch it, you have a bracket. I'm not gonna be that picky on it, okay? I just wanna make sure that you know what the difference is. So we've answered this problem. Okay, so your homework was to watch this whole video, so I hope you watched it all. Take any notes that you need to take notes on. Because then we're going to talk about in class, how do we like maybe simplify this up, maybe do another example, and then you'll have an assignment